So the problem says that a fully loaded slow moving freight elevator has a cab with total mass of 1200 kg, which is required to travel upward 54 meter in 3 minutes. So starting and ending at rest. The elevator's counterweight has a mass of only 950 kg. So the elevator motor must help. So what average power is required for the force the motor exerts on the cab via the cable? So basically this arrangement is something like that. So this is the weight that the elevator has to pull, let's say something like that, and that is basically the mass is 1200 kg, and the arrangement is like that. So it goes there, I don't have enough space, so there is a pulley here, and there is a weight counterweight of the elevator for the elevator, which is 950. So 950 kg, so it cannot pull the elevator up because it is less than 1200 kg. So the elevator's motor, it has a motor that has to work to pull it, to take it upwards, and it has to go upwards 54 meter in 3 minutes. So the question is, what is the power required for the force? So of course force is, when we say power required, that means P is equal to work over time, and work here is the applied force times the distance, like that. Since they are in sync, so the angle is 0 degree basically in the same direction. Fd cos theta, if we say dot product, work is equal to Fd, F and D there, but the force is upwards, moving upwards, and that movement is also in the same direction, so the angle is 0 degree. So Fd cos theta, cos is 0, so that's just Fd. So I'm just directly writing F times D over T. So that will be the power. So it has to go 3. If we write here, we don't know the force, so sorry, we have to find the power required, and the force here is basically the weight. So that will be mg times d here and then t. So mg is 1200 times m is 1200 times 9.8, sorry, not 1200, because 1200 minus 950, that's the weight, because this much is already counteracting. So this is the counterweight anyway, 950. If there was no counterweight, the motor had to take the whole 1200 kg upwards, but in this case there is 950, so 1200 minus 950. This is also doing part of motor's work. So the counterweight doing, so basically what I have to write here is 1200 minus 950 times G, which is 9.8, and then times 54, and here in the denominator will be time, and that is 3 minutes, that is, it has to be in seconds, so 3 times 60. So that is our, that's the expression here, 1200 minus 950, which is 250. So I can write 250 times 9.8 times 54 divided by 180, and I get 735 watts. So I will just write watts, because this will be in watt anyway, because this is the power. So that's our answer here.